let's take a look at this homework here. The quiz, the notes we took for the quiz the other day, or yesterday. If we look at that, let's see, let me find it here. Algebra 1B, that would be the wrong class. So yesterday, we wrote down some notes here for what we should be able to do, right, for the quiz. So we'll be going through this, and we talked about F prime notation, and this means slope and interpreting functions, and we'll go through that a little bit later. The other thing we didn't write down from section 1.4 would be the speed limit law, right? And so number 22, was 21 also? Just 22. Speed limit, dealing with the speed limit law, being able to talk about that. So we'll talk about number 22 and that sort of thing. So that was probably the only thing we didn't really mention yesterday as we were discussing things for the quiz. But otherwise, that was pretty, everything, hopefully everything you saw in the homework was pretty much from what we were talking about here. I don't know that there was any of this on here. And I think I gave the wrong problem number. It's number 54. I think I said 64. Number 54 back, and I think it's in section 1.4 actually. I think I said 64, but it's probably 54 we did with the height of the ball. Did I? Oh, that was something. Yeah, that was interpreting. Yeah, so it was. Yeah, so it's number 54 in section 1.4. So anyway, that would be where there'd be a problem where we kind of deal with that sort of thing. We talked about the calculator and calculating those kind of things. And then I guess I left that off there. And then in 1.7, so basically what we learned yesterday in 1.7, I think I wrote some of that down, but the connections we learned yesterday were between F and F double prime, right? F and F double prime, which actually one word would pretty much sum that up. The connection between F and F double prime is what? Concavity, right? If F double prime is positive, means F is concave up. If F double prime is negative, means F is concave down. If F double prime is 0, means you have a possible inflection point, But F double prime can't just be 0. F double prime has to switch from positive to negative or vice versa there, so that your concavity switches. Okay, so basically F double prime, that's what it tells you about F. And then, of course, we also realize that F prime and F double prime have the same connections that F and F prime have. So all of that stuff from 1.6 still holds true. Okay, so that's it. I mean, that's the stuff. There isn't really anything else that we will deal with other than those things. So if we take a look at today's homework, so this was 37 through 45, I believe, on section 1.6. So this was just another one like what we did when we did number 21 through 24 yesterday, when we did 25 through 36 yesterday, and now here's another one. Now what is this graph of? This is a graph of F prime. Very critical that we understand what that is, right? And so 37, so we'll just kind of go through this fairly quickly, but don't forget now we've got our chart handy here. Let me see if I have that. I'm not sure if I do have that. There it is. Have that kind of handy here. So if we go through this, where is F increasing, Drew? Where is F increasing?
From -3.
When F prime, now I would say on this one we would go -3 to 4. I don't think I would count it wrong if you said infinity. When it's boxed in, we kind of assume it just stops there. Okay, and I'll try to remind you that on the quiz, but if you had -3 to infinity, I'd probably take it, right? Okay, but I think it'd be better to stop because it's when f prime is positive, right? And technically it's when f prime is greater than or equal to 0. So we're okay with this point right here, right? We're okay that that touches that, but it's f prime positive, which means when that graph's above the x-axis. And f is decreasing then would be from -4 to -3, right? All right. Where does f have stationary points, Nicole? So x equals -3 and 3. We'd want to write something like that, right? X equals -3 and 3. I suppose you could do a set notation, or whatever, but I think that's a pretty good way to do it right there. Where does f have a local max, Caleb? There is no local max because what would f prime have to do to have a local max? Caleb. What would have to happen on f prime that's not there that would make there be a local max? It would have to go through the x-axis, switching from positive to negative, and it doesn't happen. So, local minimum, Logan, where's f have a local minimum? At x equals -3 because, now it doesn't say why. On the quiz I might say why is it a local minimum, so you want to say because f prime changes from negative to positive. Now, later in chapter 2 when we do this and we start working with equations instead of graphs, okay, there will be more we will do. If you say there's a local min, on this one, where's the local min? You put -3 and that's it. I'm okay with that. But there will come a point where we'll have a very specific way we're going to justify that, right? Because on the AP test, they have, when you use these chart kind of ideas, they have some specific ways they want you to justify that. And it would sound like this. There's a local minimum at -3 because f prime changes from negative to positive. Therefore, f changes from, no? Decreasing to increasing. Let's say that again. F prime, and again, the chart's got it, f prime changes from negative to positive, so therefore f changes from decreasing to increasing. That's what makes it a local min. They really want, well, the thing we've been saying, the connection between f and f prime. So when they talk about, whenever you're switching the columns, that's the kind of explanation the AP test wants, and as we go through the year, that's what I'll want. Now, this first quiz, if you say negative to positive, I'm going to be a little more lenient there, okay? But anytime you're switching columns, it sounds like, why is there a local max? Well, because f prime changes positive to negative, so f changes increasing to decreasing. Why is it an inflection point? Because f prime changes from increasing to decreasing, so f changes concave up to concave down. Or it might be because f double prime changes positive to negative, so therefore f changes concave up to concave down. That's why there's an inflection point. So they want to get that connection in there, so they want both pieces of it. Okay, so kind of be prepared for that. But we'll make a real big deal about that tomorrow. Okay, where is f concave up at 2? Jordan, what do you got there?
F is concave up at 2 times, where are we?
Number 42.
42.
Is f concave up, that's okay, at x equals 2?
No.
Because?
F prime is decreasing, right?
Because f prime is decreasing. So again, going back to the chart, f prime is decreasing, so therefore f is concave down at that point. 43, where does f have inflection points, Emerodi? At x equals -1 and 3. Is that what you said? Okay. Because I would accept, because f prime has what? What does f prime have at those places? There's f prime. Local max and local min. I think that's a good one too. I think you could say f prime has a local max or min. That's when f has inflection points. Because what did I just get done saying here in the chart? I just got in saying that if f prime goes up to down or down to up, which is what a local max or min is, then f changes concavity. So anytime f prime goes down to up or up to down, you've got an inflection point on f. So I think saying a local max or min on f prime is enough to say that f has an inflection point. Okay? So that is correct. Suppose that f of -3 equals 2. Find the equation of the tangent line at -3. So equation of tangent line, we want the slope, we want the point is negative 3, 2, so that would be this, and I need the slope, which means I need f prime of negative 3, right? What's f prime of negative 3? It's that y value right there. It is 0. So, actually, this is one we were talking about earlier today, wasn't it? So it ends up being y equals 2. Okay. All right, and then 45 is the same thing. So, but we just use different points. So y equals x minus 1 plus 3. And the slope now would be at 1. So the slope at 1 is that y value right there, which is 2. Find the equation of the tangent line. So if we knew what the f graph looked like, this would be the equation of the line that would be touching that curve. But we don't have the f graph. But all right. So that's that. So again, expect tons of those kind of things. Right? Here's an f prime graph. Answer all these chart kind of questions. Here's an f graph. Answer these kind of questions. Here's an f double prime graph. Answer these types of questions. Okay? So the chart. All right. Next one, over on page 1.7, I think this is number 14, I believe. Okay? And they tell you about, now this is what I was telling you earlier, where they give you some direction. So this is what graph? This is f this time. And they tell you that there's a point of inflection at 5, 6. Okay? So that means right there. So they're telling you, so that's the point you should use. And they're telling you that there's another one over here at 2. Okay, right in there. And then the stationary points are at 1/2. So this is 1/2. Okay? And 5/4, which is be this one. And at 5/2 or 2.5, which is that one. Okay, so they're telling you what those values are, so that's what you should be using. So, where is f double prime positive? Where f is up, right? F double prime's positive when f is concave up. So f is concave up between those two right there. So it's got to be an interval, right? 5, 6 to 2. Does it got to be that? That's where it's concave up, between the inflection points. Okay, where is f double prime negative? Well, when it's concave down. So that would be 0 to 5, 6, and 2 to 3, right? Now again, did you go to infinity? Did you assume that went to infinity? Didn't have arrows, so again, I'll try to be really specific about that for you. And then when is f double prime 0? At those points, 5, 6, and at 2. Okay, there's a change in concavity at those points. All right, because that is the f graph, and that's what f double prime tells us about those. Okay, 15 through 22. So this time it's G double prime, and so we're going to ask all kinds of different questions. So G is concave up. Joe, where is G concave up?
3 to 0.
Okay, say that again.
3 to 0.
3. Did you say 0 to 3? Say it again, Joe. 3 to 0 doesn't make sense to me because that's big to little. We always want to go little to big. Where are you looking on here? And I might not be hearing you right. Where is G concave up is what? With G double prime, so just 0 to 3. There you go. Yeah, I don't know. 0 to 3. 0 to 3. And again, we're not bothered by this part right here. We're not bothered by this part right here. We just got in saying when G double prime, that previous problem, we said G double prime was 0 at those inflection points, right? But remember, on the chart, when G double prime is 0, we said when the second derivative is 0, we said that's a possible inflection point on the original, right? Now, when we have those inflection points, it's true, it works the other way. When you have an inflection point, then it is 0. Now again, all of these things I'm saying right now are assuming we have nice, smooth curves, no weird gaps and sharp points, right? On the quiz tomorrow, we're going to throw that stuff out. The sharp points, where the derivative's undefined, that kind of stuff. The only question you will be asked about that is if I specifically give you a graph that's got a sharp point or something and ask you about its derivative, it's undefined there. Okay, so that's a basic thing we need to know. But on the chart questions here, we're assuming all of that stuff, right? Whenever we're talking about concave up and all those kind of things, I'm not going to give any local maxes that necessarily have a sharp point, that kind of thing, right? But if you do see a graph with a sharp point, you need to know the derivative doesn't find there, yeah. That part we're okay with. But otherwise, when I'm asking these other questions, it's just nice, smooth curves, okay? So, if the second derivative is 0, it's possibly an inflection point, but doesn't have to be. So, right here, the second derivative is 0. We don't have a change in concavity because G double prime is positive and then stays positive. So, G would be what? G double, I said a lot there, so let's pause the thing. G double prime is positive, then stays positive. What's G? Concave up and stays concave up, right? So we're fine. So when Joe said 0 to 3, we're okay that it hit there. It stays concave up. Now, if the question would have been, when is G double prime positive, would we have included that point? Because it's not positive there. It's 0, right? So two different questions. Very closely related, but they're still two different questions. So where is G concave up? 0 to 3. We're fine with that, which is when it's positive, which really, in that case, we mean greater than or equal to 0. All right, where is G prime decreasing? Macy, where is G prime decreasing? What'd you have for that one? On 16. 3, 2, 4. G prime decreasing, let's check her out on the chart. G prime decreasing would be when G double prime is negative. Yeah. Okay, and that's what she's got. G double prime below the x-axis from 3 to 4. Very good. 17, does G have an inflection point at 1? Jasmine? No. Actually, we just talked about that, didn't we? It's a flat spot on G prime, and inflection points, we just said a minute ago, happen on what on G prime? Local max and mins. Local max and mins on G prime, right? So that'd be one way to say it. Another way to say it is, if you were having to explain why, is G double prime is positive and stays positive. We just said it a minute ago. So there's no change in concavity. So it is not an inflection point. Number 18, is there an inflection point at 3? Anybody?
Yes.
Yes, because we do have a change in concavity. G double prime goes positive to negative. Again, here it is. G double prime goes positive to negative, so G goes concave up to concave down. We have an inflection point. All right. Rank these points. G prime of 0, G prime of 1, G prime of 2, and G prime of 3. Which one does it, what does it say? Increasing order. So which one of those is the smallest? G prime of 0. Because what did we say a little bit ago about the G prime? Well, actually, I don't think we specifically said it. From 0 to 3, G double prime is what? Positive. So therefore, G prime is increasing, right? So that would probably be the smartest way to do it. Since G double prime is positive all the way from 0 to 3, G prime's got to be increasing. So if G prime's increasing the whole time, they're already in order, aren't they? Just like that. If the G prime graph's going up, then each value is going to get bigger as you go. So they're already in order, just like that. Okay, so that's how you use the chart to answer that question. Is G prime of pi greater than G prime of 3.5? That's like asking that.
Yes.
Yeah.
I think it's yes, right? Because what's happening, it's a reverse of what we were just saying. What's happening on G prime after 3?
So it's decreasing.
It's decreasing. G double prime's negative, so G prime's decreasing, so the G prime graph's going left. So 3.14 is to the left, or excuse me, going down. 3.14 is to the left of 3.5. The graph's going down. Which one's greater? The one before, right? 3.14 would be above the value of 3.5, so it's true.
Isn't G prime is still increasing from 3.14 to 3.5?
No,
Or
because G double prime's negative.
I was thinking between two.
Yeah, between 3 and 4, because we just got to talk about G prime increasing on these, right? But after 3, G prime is going down. Okay? G prime is going down. So if I was going to plot G prime, yeah, here's 3.14, and I don't know where it is, but let's say it's there. And here's 3.5, and this graph's going down. So there's 3.5. So the y value of 3.14 has got to be bigger than the y value of 3.5. Yes, Laura.
So when we're dealing with how large the numbers are on the G prime graph, do the y values on a double prime graph have anything to do with it?
Yes, from the standpoint of whether they're positive or negative.
Okay.
Because when we're trying to tell if the G prime graph, did you ask me about the y values on this graph?
Yeah.
G double prime, right? Yes. When we want to know if certain y values are bigger or smaller than other y values, it has to do with whether that graph is increasing or decreasing. That's what it has to do with. So if we're asking, let's go to the chart. So if we're asking if G prime has bigger or smaller y values, right? We care about whether G double prime, we care about whether that graph is increasing or decreasing. So we care about the y values on G double prime, whether they're positive or negative.
Okay, but
Does
it's
that
just increasing like the farther, like the longer it's in a positive, or decreasing the longer it's in a negative.
Right. Okay. All right. And again, one of the reasons I like to go over all these, and we talked about this on our first quiz. There's always going to be, and one of the themes of this class all year long is we really want to understand the concepts of what's going on. It's not just me standing up here, work an example, of the same type, and then you do homework of a whole bunch of the same type, and then we quiz over a whole bunch. It's just not that way. There are some things in calculus that are that way, but a lot of it is more conceptual. So we try to understand these concepts. We use little gimmicks like the chart to try to organize our thoughts on these concepts. But you want to be able to, if you understand the concept, be able to answer a lot of different questions in a lot of different ways that really are all about that same concept. And that's what we're seeing here. So this is by going through all of these, because they're all getting at the same stuff. They're all these things that are in the chart. They're just asking a lot of different ways. And so we're trying to exhaust all the different ways I can ask these questions, right? But there may come a few on the quiz that get at it a little different way. But the vast majority of them that you see on the quiz are going to be very similar to things you've seen here. But there's just a lot of different ways of thinking about it. Okay, onward. Suppose that G prime at 1 is negative 4. Is G decreasing at 3? So here, this is interesting. This is 21.
Yes.
So I was starting to draw a G prime graph over here, so let me do that a little better. So if G prime of 1 is negative 4, so here's 1, here's negative 4, so here's the G prime graph. Okay? And then they ask me at what? At 3. They want to know what's happening. Now this is the G prime graph. All right, so now before I do any more, and again, I was telling some people this morning, we've been mostly doing graphical kinds of stuff here, right? So whenever I see that they give me a point, I go plot it right away, because I'm figuring a graph might be a good thing to look at. They're asking me, so now let's forget it. I've plotted that point. Now just forget it for a minute, and let's look at what they're asking. Is G decreasing? right? Well, how would we tell if G is decreasing? If G prime is negative. So the question really is G prime negative? That's the question I want to answer, right? Is G prime negative? Well, right now it is. But the question is, when it gets over to 3, is it negative, right? So the question really is, when it gets over to 3, is this graph still down below? Or has it went up above? Well, what will determine whether it's still down below or up above? The slope. So this is when I said 21. This kind of is a speed limit law in a different way. But the speed limit law is if you know where you start and you know how fast you go, which is your slope, you know where you end up. So this really is kind of in disguise a speed limit law. So how do we tell the slope of G prime? Oh, G double prime, right? We have the slopes. These Y values are the slopes. So between 1 and 3, what do we notice?
The highest the slope gets is.
The highest it gets is about 0.5, it looks like. So here, kind of back to what Lauren said, here's kind of the first time we've really cared what these Y values were here, right? We cared if they were positive or negative, but we didn't really care what they were numerically, did we? It's the first time we've really had to, but we do on this one. All right. I'm sure it's important, but not important as this. All right. So the biggest the slope ever gets is about 0.5. Can we agree on that? Okay. And 0.6 if you want to, or 0.7 if you want to be safe. So that means if we go over how far? No, 2. From 1 to 3. So if we go over 2, let's say it's 0.5. So if we go over 2, how much we go up? 1. Does that get us above the x-axis? No way. What if, let's really hedge our bets. Let's say it's all the way up to, I don't know, even if it was all the way up at 1, which it clearly is not, right? What if it was all the way up to 1? If we go over 2, we'd go up 2, we're still well down here, right? So we know for a fact, because of what these Y values are, so it's really speed limit law. We know, since G double prime is the slope of G prime, we know the slope is about 0.5. If I go over 2, I'm only going to go up about 1. So therefore, G prime is going to be negative. So therefore, G is decreasing. Really good question there. Really good question, because you really had to look at a couple layers there to get it. Okay? All right. And 22. So now 22 is separate from this. So we'll just look at this one. So 22 is definitely a speed limit law. There's a lot of language in this that you ignore. F and F prime and F double prime continuous, great. Negative infinity to infinity just means it's nice and smooth. Then they say F prime of 2 is negative 1. Okay, so right away I'm going to graph that thing. And I got 2, I got negative 1. Okay, and I got F double prime, which what is that? That's the slope. It tells me is between 0.1 and 0.5. So this is definitely a speed limit law. So this is telling me where I'm going to start on the F prime graph. It's telling me my slopes have to be between 0.1 and 0.5. I think a picture is the best way to do this. Now you can try to plug into the formula and probably show some things, except the formula didn't show an in between. So maybe you just take that piece, and try to do it. But I think you just do this. You say, okay, at 2 we get negative 1. They asked me about F prime of 3. Now you might be thinking, what about all that stuff about x's between 2 and 4? They're just saying that these are the slopes as long as you stay between 2 and 4 in here, which we are. Okay, so that's doesn't really matter. Find the upper and lower bounds on the value of F prime of 3. So in other words, what could F prime of 3 be? Upper and lower bounds, that's what they're saying, because we have upper and lower bounds here. Okay, so that means if I go, so here's 2, going over to 3. So if I go over 1, what can I do? I can go up 0.1, or I can go up 0.5, or anywhere in between. Well, what would that be? This would be negative 0.9, negative 0.5. So my y value, so f prime of 3, a great way to answer this question would be, and I don't know if I should put equal to signs on it, probably not, because these don't, so I would probably leave those off. Okay, so f prime of 3 would be somewhere between negative 0.9, we always want to put the littlest one first, so somewhere between negative 0.9 and negative 0.5. So a picture like this would do it. You could maybe even write a sentence or two to explain it even more fully would be nice, but you know, a picture like this along with that is pretty good. Okay, so that's a pretty just pretty basic speed limit law right there. So we want to be able to do that. All right, onward. 25. Was that next? No.
Yes.
Yeah.
Yes. Yes, it was. Okay. 25. So we've got these graphs. Oh, this is just a matching thing, wasn't it? This is just a matching thing. So the left-hand column is F, right? And then you got F double prime over here. Okay. All right. So F and F double prime, the key word is concavity. Positive, so really if I go back to my chart, the only thing I care about when I'm going F double prime to F is positive, negative, really. Concave up, concave down. So when I look at this, break it down to that, all I really care about is this goes negative to positive to negative. So therefore F would go concave down, concave up, concave down. So concave, concave down, concave up, concave down. So C goes with that one, right? Okay? This one over here. 0. No concavity ever. Got to be that one. The linear line. I like it. What about this one? Negative always. So concave down always. And then this one, positive, negative, right? So it's got to be concave up, concave down, concave up, concave down. Interesting, they look almost identical. And they're not identical, but they're very, very similar, okay? As far as their equations, what their equation. Okay? All right, good. So, matching situation there. 27. I do not have a picture of this one, so let me turn on the camera here. Now this one was a tricky one from the standpoint that you had to. Oh, really tricky.
So, oh, is it different?
Yes, I am. Thank you.
No, we didn't.
Oh, yeah. So, yeah.
Wait, Emily?
Emily, yes, she was on it. Now, this one's tricky because a couple of these graphs are really close to each other as far as what goes on. But, and I apologize to anybody listening on the video. We're doing number 27, but you're not getting to see this. So, what do you think? F prime, F double prime.
BAC.
Shout it out. BAC.
I thought it was CAB.
CAB.
Yeah,
Anything other than these? BAC, raise your hand.
Oh, shoot.
Some of you are just going along. All right. BAC. Well, let's check it out. That's what most people think. So let's see. BAC. So if I was doing this one again, I told you I would look at the x-axis. So right there, I would look at that, and it's going from negative to positive. I'm going to think of that F prime F relationship. First thing we learned, easiest thing to deal with. Let's deal with that. So F prime. I look where it's 0. First thing in the chart is when F prime is 0, you got local max min or flat spot. So this goes negative to positive, which means I better have a local minimum. So this one right here, this dotted one, which is C, could be F prime, and a local min right there could be F, right? And so that's what you guys were saying. No, nobody was saying. Nobody said F prime could be C, right? Because what else could be happening? It could be F prime, F double prime, which I think is what you guys are saying, right? You're saying A is F prime, and you're saying C is F double prime. But let's check the one I had black here first. So that means B, and the first one I did, B would have to be the second derivative, right? If I'm doing this, the black. Okay, so this one would have to be the second derivative. Now, what do I know about second derivative? We've been saying it all day. Positive and negative means F is concave up or concave down. So this graph is negative till here. So F, where's my F, would have to be concave down. Oh, it's clearly not, right? I mean, this graph that I thought was F double prime is negative, and the one I thought was F is concave up. Well, that doesn't go together. So I can eliminate that right away. Okay, so now I feel pretty good that that's got to be it. So this one would have to be F. Oh, this one maybe wasn't as tough as I thought. I thought there was.
Pretty.
Must be another one that I've given. Where two of the graphs. Well, I did when I was looking at it. I thought, wait, they don't look the same. I'm given one where two of the graphs almost looked identical. They crossed at the same places, but one of them went a lot higher than the other one. So you had to actually look at the slope values, the y values, to see how steep the other graph was compared to the other one. So it got a little trickier. Maybe that's the one I do in the quiz. All right. So.
Yeah, can we go over
So, I don't know where.
Go over that one in class.
I thought it was this one. All right. So if this is the case, so now I would check my FF prime maybe, or let's just do the concavity again. So if this one's F double prime down here, it's negative here in the beginning. So my F graph should be concave down, and it looks like it is for a little while. Then it switches to positive the rest of the time. So no, wrong one. The dotted one. So the dotted one's positive, so this F graph's got to go to concave up, which it does until there, okay? Then it switches back to negative, so concave down until there, looks like, inflection point. And then positive till there, so concave up, then goes negative, concave down. So if I'm just looking at the FF double prime, I got that concavity thing going on, okay? So the things to really look at, the main connections we have, F and F prime, and again, I think this is good just to review the chart. If I have my choice here, so BAC looks good for that one. If I have my choice on the chart, right, if I've got a problem where I can look at a lot of different things on the chart, where's my chart? Okay, I'm going to focus on this part. When it comes to F and F prime, I'm going to focus on this part right here, right, where F prime is positive and negative and 0, because that tells me about local maxes and mins. And if I'm doing F double prime and F, I'm going to focus on where F double prime is positive or negative, because that tells me the concave, right? So if I want to know stuff about F, local max and min, I'm going to look at F prime. If I want to know about concavity, I'm going to look at F double prime. Now, it's possible I don't have F double prime, right? So if I need to know about concavity on F, then I have to look on F prime and increasing, decreasing. But that's what we were saying earlier. Local maxes and mins on F prime are the inflection points, right? So you can get it. It's all in there. And you start to, as you work with it more, you start to realize the more important ones, the ones you're going to look at first. And I like a problem like 26, 27, because you don't have to look at everything that's in the chart. Just look at a couple of things. Okay. Now on the quiz, if I give you one like that, I want you to explain why. And again, you don't have to write out every connection, but write out some of the main connections that are making you choose that one. Okay. All right. And is that about it? What? Oh, we had the ones. Yeah, we need to get the calculators out here a little bit. So let's do that. We'll quickly go through 32 and 33. But let's see. Who's my presenter today? Emily, man, you're busy today. Okay, so let's see, that's not what I want. So 32, quickly, 32, sketch a graph where F is greater than 0. F is greater than 0, F prime is greater than 0, and F double prime is greater than 0. So, what's that mean? What's that mean?
Yeah.
Above the x-axis. We're graphing F here now. What's this mean? No. Now, I heard it's always positive. Careful here. We're talking about F. F's always positive. Slope's always positive, which means what, though? Increasing. I think that's what we're going to say. So, we got an F graph that's above the x-axis. It's increasing at an increasing rate, which means concave up. So we're looking for a graph that's above the x-axis, increasing, concave up. So a really easy one would be the e to the x graph. E to the x graph is always above the x-axis, it's always increasing, and it's always concave up. You could do the right half of a parabola if you wanted to. You wouldn't have to have one that just goes forever. You could just say, well, how about that? The right half of a parabola would be that. Above the x-axis, always increasing, always concave up. Okay? The next one said the same thing, except they wanted F prime to be negative. So now we need a graph that's above the x-axis, decreasing, always concave up, right? Y value, we want F to be positive. We want its slopes to be negative, which means it's decreasing. F is decreasing. And we want concave up, right? Increasing, decreasing at an increasing rate, if you will. Okay, well, what could that be? Well, that could be the left half of a parabola, right? It could be the e to the negative x graph, right? That would always be above the x-axis. It would always be decreasing. And it would always be concave up. Okay? All right. So, 44. Let's go to your graph screen, or 43. Let's do that one. That was more interesting. So, let's graph this. Now, again, I think 43, to be honest, it would be fair to put that on the quiz. I'm not going to put that on the quiz. We're not going to, for time's sake, I have, to do certain things. But and I think it would be fair to put it on the no calculator part. But if, I think we should be able to draw a graph of that thing right there. It's going to be what kind of a polynomial? Q. Because if you FOIL that out, multiply it all out, your highest power would be an x cubed. We know an x cubed kind of goes up, down, up kind of thing. It's got a couple of roots. Now here's, again, one of the reasons we haven't run into all this yet, so I'm not gonna throw this on here. And I'm sorry, let's do 43. Let's do 43. And so what happens on 43? So as she's getting this on here, we got x plus 1 squared. So it has how many roots? Well, it could have 3, but because it's in its factored form, it only has 2. We can tell there's one here at -1, and there's one here at 2. The one at -1 is called a double root. Now, whenever you get this factored form, if you get one that has a power on it like this, like a double root or a triple or something, that means it's going to bounce off the x-axis. So when you get one like this that's at -1, and you never probably talked about that back in algebra class because it didn't really care if it bounced off, you just care if it touched. But now we realize that that has to do with flat spots, stuff like that, right? So it is a big deal. So because of that, it bounces off at -1 and it's going to actually go through it too. So those are things that as we go down the road may show up in a no calculator kind of thing. Okay, but we're going to stick mostly with graphs, and because I'm going to keep the calculator part of this short, if I was putting it on there, I'd put it on the calculator part anyways, but it's not going to be. But we've got the graph, so now we're just asking these same kind of questions we've been doing. So they say, where is F concave up? Now remember, this is F. What is this graph? F. It's double prime, again. So we're really thinking about the fact that this is negative and then switching to positive, right? So, where is F concave up? Well, it'd be when this is positive. So from 2 to infinity, okay? Where is F prime decreasing? That's when F double prime's negative. So, up until 2, negative infinity to 2, okay? How many stationary points does F prime have? F prime has stationary points when F double prime is 0. So it has 2 at -1 and at 2, which is what they wanted, right? Where are they? X equals -1 and 2. Does F have inflection points? F have inflection points when, I don't have my chart. When F changes concavity, which is when F double prime changes positive to negative, right? Positive to negative. So F double prime changes right there at 2. So we've got a change in concavity, right? A change in concavity. So at X equals 2. And then sketch a graph of F prime. So this is probably the one people had a question about for the most part.
Would you write like that X equals 2 is a possible inflection point?
No, X. Great question. Here's why we said on the chart, we talked about possible inflection point. What we said on the chart was that, what we said on the chart was when F double prime is 0, you have a possible inflection point. So on this graph, we have a possible inflection point here and here. Which one is an inflection point? Where the concavity changes. When it actually changes from negative to positive or vice versa, that's when you have an inflection point. This isn't because it didn't change. That's why. So the inflection point is actually at 2. Okay, good question. Sketch a graph of F prime. All right, so what are we looking at on this graph then, since this is F double prime? We're looking at the Y values, right? We're looking at the Y values because those are the slopes of what I'm about to draw. Right? F double prime Y values are the slopes of F prime. So I look down here and I got a Y value of big old negative, -16. That means my graph's got to be steep and going down, right? So since I'm going to be going down, I'm going to start it up here. So it looks like it's going to be going down, 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 and just forever, right? Just because this is going down forever. And then what's happening? These Y values are negative and getting less negative. Now what's happening right there? Flat spot. So this is getting less negative, coming down like so, flattens out right there. But then the Y values go back negative. So now that means it's going down some more. Right? Now, we probably should have zoomed out. I tell you what, let's do that. Let's zoom out a little bit.
Zoom out?
Yeah, let's, just do zoom out. Just do zoom out. Right there is fine. Oh my gosh, I think we zoomed in. Oh no, we didn't.
Zoomed out.
I was like, are you sure you want to zoom out? Like,
Always listen to me, no matter what.
that's gonna make it way harder.
No matter what, no matter what stupid thing I say, just listen to it. That's good. All right, number 3.
Okay, is that good?
No, go down a little bit though with your thing. There you go. No, not that far. Right in there. You see that? You trust me. All right, that's better. All right, so now, sure, that's going to be done. All right, so we're going to go down, 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 and then it's going to flatten, we said right there, because the slope is 0, and then it's negative and getting more negative until there. So that means it's going to go down, 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 steeper till there, and then what? And what's happening right there? Local minimum, and then positive, positive, positive means it goes up. Okay, now remember, this is F double prime in blue, and it's F prime in red. So it's just like when we did the F prime to F, right? So there's no concavity we're talking about. And when we were saying earlier, when F prime has local max and mins, F has what? When F, give me a second to think about it. When F prime has local max and mins, what's F have? Inflection points. So the same thing would be true when F double prime has local max and mins. F prime has inflection points. So right here and here, where F double prime had local max and mins, F prime had inflection points, right? And where this hit 0, F double prime, F prime was flat. Flat spot and a local min. Okay? All right, something like that. All right, and then the other one is pretty uninteresting actually. E to the negative x would be that. If that is your F double prime, I mean, what's going on there? It's always positive. So F is always concave up. Where is F prime decreasing? Well, it'd be when this is negative. Never is. Okay. Are there any stationary points of F prime? No, this is never flat, or it's never zero. The slope it never crosses, so the slope, F double prime, is never zero. No stationary point. Does F have any inflection points? Inflection points are when F double prime would switch from negative to positive, which it never does, right? I mean, so, and then sketch a graph of F prime. So, that would be the most interesting of those problems. So F prime, so these are the slopes. So this Y value out here is what? Big and, no, we're looking at this Y value, right? It's up here positive, so that means my graph's got to be going up. So it's going up, so I'll start down here. So it's going up, but it's
Getting less up.
getting less up, right?
Getting less up.
Well, I guess so. Going up at a decreasing rate, I guess we'd say. So it's positive and getting less positive and continues to get less positive. And so these Y values are getting closer to zero, which means a slope. So it's getting closer to flat. So it's probably just something that looks like that, right? And it is. I mean, that actually is what's happening. It's really just a reflection. It turns out it really is just a reflection. Remember how we said e to the x had its own Y values where it slopes? Well, e to the negative x, actually, the Y values are the opposite of the slope. So if this has a Y value up here of, say, 4, then down here, it's a slope of -4, or it's a slope of a Y value of -4, right? Its slope there is -4, so that'd be a -4. And so it is just a reflection on that one. Okay? So, all right. Really, there's not much to talk about as far as review. That was pretty much it. I mean, that's our review. We went through a lot of that stuff. There is the problem with the velocity and all that stuff. Yesterday we did talk about the whole business with the calculator, and okay, if I would go back to this, being able to zoom, and just calculate a slope, so make sure you can do that. I don't think there's much to do with that. It's just you've got a function and you want to estimate the slope of 2, you just pick 2 points really close and do a slope calculation. So that's about all I want you to do with the calculator. The rest of it is all this other stuff. Interpreting, you might look at some of those. And I've got some in our review problems for you to do here. So let's go ahead and just do that, talk about that next. So I'll give you the rest of the time to work here. So on the review, there are some problems there. I'm going to give you certain ones to focus on here. So at the very bottom of the assignment sheet's a whole bunch of review problems. I'm going to write down the ones that would have to do with the quiz. I originally just wrote down a bunch of them that have to do with the whole chapter, but these are ones that would have to do more with the quiz. So if we did 14 through 22, 25, now 25 would be one you could use your calculator on. Okay. 28 through 33. Now I'm not going to go around and check on these. These would be good ones to review probably. 38, 39, 41 through 51, 61, 76. It is pretty much, isn't it? It's not some of the ones at the beginning. 84. 86 through 91. I'd been better off just telling you which ones to cross off with.
Yeah.
But, do what you want on those. There are some good ones. If you want to work on interpreting, what certain things mean, some of those are at the end, like 76, like 80, like 84. Those talk about, that how many daylight hours per day, that kind of stuff. There's a few speed limit law in 28 through 33. This section right here is kind of speed limit law kind of problems. Okay, so if you want to be doing those. Oh, hey, there it is. I just saw it. I just figured it out. Well, remember the one I said that was kind of tricky?
That's gonna be on the test? Yeah.
Well, maybe it's not now, I don't know. It's number 15 on your review. If you look at the dotted one and the dark blue one, they're very similar. Other than one's got bigger Y values than this one. And so that plays a role in choosing which one is which. And the other thing they do is they say one is F prime, and one is G, which is just not even related to the other ones. So that one is one of them that I put on there. So, okay. So again, I would not say that these problems is an entire full review. I think it's pretty good, but I think you got to go back to the notes we took as far as make sure you do this, make sure you do that, whatever. I think this encompasses it pretty well. But looking back at the old homework problems is a good idea too. All right.